So the purpose of this CCNA community is to help my brothers outside there. So guys, I want you to know that when we talk of the CCNA, if you want to become a Cisco Certified Network Associate, you really need to do a lot of work to earn these certifications. Some of us have already earned it. Some are just doing some revision based on what is going on. So I welcome you all to this platform. I'm grateful to see you guys pushing, doing all in your own little way to make sure that this thing go successfully. And I believe in every step when it comes to IT career, every step you take today, it will pay you handsomely at the end. So in today's, we are going to discuss about the OSI model. In the previous session, we already covered the fundamental of networking, and now today we are going to dive in the OSI model. When we say the OSI model, the Open System Interconnection, the OSI model is being developed for networks or devices to intercommunicate. For an example, you have a Windows PC or a Windows computer. Then you have an Apple computer. You know that before connecting, you need to run an RJ45 cable between these two cables. And those two cables, you need to make sure that any end of these two cables have an RJ45 connector. And these connectors need to survive through the NIC, network interface card, in these two pieces. If you connect these two pieces, take note. The first PC is Microsoft. The other PC is Apple. They will not work. In the early days, they will not work. So there comes in the OSI model handy because they want the two operating systems to communicate successfully. We need to create a standard wherein if someone have PC with Microsoft and someone have PC with Mac OS, these two PC, you can connect them with Ethernet cable, they can communicate. When you think of an OSI, it's just an idea. Just think this is an idea wherein we need to create a standard. Let the platform, all of the vendors follow a one standard, a one protocol. With this protocol, if I use RJ45 cable, I connect it with Dell, I use the same end, connect it with Apple, they're supposed to communicate successfully. This OSI have 7 layers. Application layer, we have the presentation layer, we have the session layer, transport layer, network layer, data link layer, and the physical layer. These layers communicate from the top to the bottom. When the communication is flowing now from the top to the bottom, what will happen? This is what we call the encapsulation method. The packet is encapsulating from the top to the bottom. When there's a reply now between PC1 and PC2, now the data will move from the physical layer to the application layer. Now in that time, that's what we call the decapsulation method. Let me share my screen with you guys. Okay, to explain the OSI model into details now. Now this is a slide. As you can see the slide, we have mom's PC here. Now we have Aisha's PC here with the 7 layers. Now if mom's PC here want to communicate now to Aisha's PC here, what will happen? This packet need to follow the rules and the standard, the layout standard. Now as you can see, this is the 7 layers. We have the application layer, we have the session layer, the application, the presentation layer, the session layer, the transport layer, network layer, data link layer, and physical layer. These are the 7 layers. So these 7 layers, what will happen? When Aisha wants to send a packet, let's say for an example now, Aisha wants to send an email now to, let's say mom wants to send here a packet now to Aisha. The packet will first be within this application layer. Mom will be in this application layer. During the application layer, we have protocols that Mom will be using to communicate with Aisha. Application, when we talk of application, one of the application is a web browser. One of the application Mom will be using to send an email to Aisha is web browser. Web browser like this, Firefox, you understand? This Chrome. These are all application layer Mom will use here to communicate to Aisha here. Now, when the data or the PDU, protocol data unit, is in this range, the application range, what will happen? It will move now from this application here because Mom have already clicked to what we call, Mom have already clicked on the web browser, which is Chrome. Now Chrome Mom have already signed into Chrome and sent an email. Now the packet now will move from the application layer to what? To the presentation layer. To this presentation layer. To the presentation layer. When the packet is in the presentation layer, one thing you need to be aware of now the presentation layer do data formatting. Let's say for an example, Mom now is typing an email. Now this email typing formatting takes place within this presentation because Mom is now seeing the thing he or she is working on to send to Aisha. So that's where the data formatting happens. Here, application is where the browsing happens, the application stuff like the Chrome, Firefox stuff. Now, when it's reach here, the data formatting happens here. Mom is now seeing the work, the thing he or she is working on here. So now, from here now, it moves to the session layer. When there is a session, for an example, let me think of, like, let's say a session, example of a session between Mom and Aisha is that, for example now, Mom have just logged in, use the browser, do the typing, log in. Mom have logged into to her email account. Now, when you log in, when she log into the email account, what will happen? Mom have created session between the server, the authentication server, with Mom. So now Mom can able to send a message to Aisha. There is now session between there is now session between Mom and Aisha, or there is a session between Mom and the authentication server. You understand? So now we move from the presentation now, we move next, the data or the PDU will now move to the transport layer. When it moves to the transport layer, something now will happen. Within this transport layer, there's connections now. We have what we call connections, port numbers, source and destinations. A lot of stuff now happen, protocols happen here. And one of the main things you will see here, you will see something like the TCP and UDP ports. The TCP and UDP port within this session, within this transport session, Mom is either using what? If Mom is using a TCP or a UDP, will happen in this particular layer, this transport layer. If Mom is using the TCP is more connection oriented. Why? If, for an example now, if Mom say hello, how are you doing? If the connection between Mom and Aisha, is using TCP, then Aisha said, I didn't hear the end, like the how are you, what will happen? There will be a connection back telling the TCP that the end tail of the voice didn't reach. So the TCP will make sure that there is connection oriented between the two users. Definitely TCP will try to resend the ending of the data. That's why TCP is connection oriented. But if there is, let's say for an example, there is a connection between Aisha and Mom, but Mom said, hello, how are you? But what happened? the connection between them, they are using UDP. If Aisha didn't hear the how are you, that's how it flows. UDP flow with connections between the two sides, while the UDP is connectionless. Will not ask for another reply, just sending. That's why, like for an example, most people that stream, live video streaming, they are using the UDP. The data now will now move from the transport layer to the network layer. When it comes to the network layer, the IP stuff, the routing, all happen within this network. When it comes to IP addressing, routing packets from one side to another side, it's all happen within this network layer. Now we'll move to the data link layer. In this data link layer, it come here. Now, here we only care about MAC addresses, marking the source MAC address and the destination MAC address. All the source MAC address and destination MAC address now will be happening through this platform. Now this packet now will move now from this data link layer to the physical layer. When it reaches to this physical layer, what will happen now? During this physical layer now, convert now to bits. The data now will move from mom's PC to Aisha's PC. So during the process when this data is moving from this top, application, presentation, session, transport, network, to this physical, call it the encapsulation method. The data is now moving from the top to the bottom. Yes. From this physical to the top, the application, we call it the encapsulation method. Encapsulation method is from the top to the bottom, whilst decapsulation method is from the bottom down here to the top. Now with the TCP, see, you can now see that we only have application, transport, network, data link, and physical. Why? Now the TCP now have bundled the application layer, the presentation layer, and the session layer, making it now an application. On the transport, take note, if the packets now have moved, when the data, the PDU with this application move to the transport, now its name will now change to segment. The data move to this session, to this transport layer, we don't call it anymore data. We call it segment. Why segment? Because the TCP have this quality. TCP or UDP, when you have a packet, TCP will not just send a whole payload. It will send it segment by segment. It will send it segment by segment until everything is successful. So it will not just take a whole bundle and transfer it that way. No. That's why the data now name change to segment. If the data now move from the transport layer now to the network layer, network area, here a lot of stuff happen. We do routing, we do IP, we do NATing, all those things, access lists, all those things will fall within this network layer. It's now moving from the transport layer to the network layer. Now we don't call it now segment, we call it packet. Now the packet now is moving from what? From this network layer. Now the packet now is moving from this network layer to what? To the data link. To this data link. If the packet move now from the network layer to the data link, name of the data will change now to frame. We call it frame because the PDU or the data is now in the data link layer. Now within this layer now, the packet is now moving from the data link layer to the physical layer. But when it moves to the physical layer, now we call it bits. Network layer here. Within the network layer here, we have just mentioned that the data now is packet, but the device that operates within this layer, we call it the router. The router you are seeing, routers, they operate within this layer. They operate within the network layer. When you talk of network layer, bear in mind that router, devices like router or layer 3 devices or layer 3 switches, we have routers and layer 3 switches, they all operate within this network layer. Devices like routers, they operate in the network layer. Now, within these routers now, we have what we call routing, IP addressing, all this happen within. NAT, access list configurations, you do all those things within this router here. So now, now let's say to the data link now. The data link, we already know that when the packet is in the data link, we call it frame. So now within this frame, the device that operates within this data link, we call it switch. A layer 2 switch operates within this data link. Other devices don't operate here, but a layer 2 switch, when you say a layer 2 switch, you already know what is a layer 2 switch. The functions, the role they play. So they function within this data link layer. Now, fast forward, we move to the physical. Now, within this physical now, the devices, we think of like the cables, the hubs, they all operate within this physical. The physical now, these are cables, devices you use to interconnect. The acronym I have created, like if you said, please do not, like this, these are the acronyms you need to be aware, because you, in the system, they expect you to know every platform, every functions within these layers. Please do not throw sausage pizza away. Place from the down to the up. Please do not throw sausage pizza away. Or you can use, please do not touch Superman's private area. Like with this, you can able to align these letters. Like the please here stand for what? For this P, and the D stand for the data link, and this, the N stand for the network layer, and the T, the throw here you are seeing, stand for what? The transport layer. The sausage is session layer, the pizza here is the presentation layer, and the away here is the application layer. So with just these two acronyms, you can able to use one to remember, for you to able to remember how these OSI layers operate.